Hi guys, this is IGCSE O-Level Chemistry, paper 22, March 2020, question 11. Aqueous copper to sulfate is electrolyzed using carbon electrodes. Which statement is correct? Bubbles of hydrogen are formed at the anode. So we have got aqueous copper to sulfate present. Since copper is less reactive than hydrogen, so copper will be deposited at the cathode and we would have oxygen gas being produced at the anode. So none of the electrodes have hydrogen being produced. So this statement is incorrect. Next, bubbles of oxygen gas are formed at the cathode. No, oxide ions release electron to form oxygen gas. So this is oxidation, and oxidation takes place at the anode, not at the cathode. Next, copper is deposited at the anode. Copper ions accept electrons to form copper metal. This is reduction, and reduction takes place at the cathode, not the anode. And lastly, the blue color of the solution fades. Yes, this is true because the only source of copper metal is the copper ions in the electrolyte copper 2 sulfate. So when copper ions will accept electron and deposit as copper, the color of copper sulfate solution will fade, and this is represented by the blue color of the solution fading. So option D is the correct option for this question. Question 12. Nitrogen trifluoride is used in the manufacture of certain types of solar panels. The equation for the formation of nitrogen trifluoride is shown. So, using the table of bond energies, what is the energy change for this reaction? So, the energy change would be represented by the sum of enthalpy of reactants minus the sum of enthalpy of products, because energy is needed to break the bonds of the reactants and energy is given off to form the bonds of the product. So giving away energy is represented by a negative sign and requirement of energy is represented by a positive sign. So the bonds that are broken are a nitrogen-nitrogen triple bond, and we have three fluorine-fluorine single bonds being broken. And the bonds being formed are six nitrogen hydrogen single bonds. So the energy that is required to break the bonds will be 950 plus 3 into 150. This would be the energy required, and the energy given off would be represented by a negative sign. And we have 6 moles of NH bonds being broken. So this would be 6 into 280. So this is the calculation that needs to be performed, and the answer we get after doing this calculation is equal to minus 280 kilojoules per mole, which means this is an exothermic reaction because it has a negative sign. So this eliminates option C and D, and the numerical value of 280 is represented by option B, eliminating option A, making option B the correct option for this question. Question 13. Which statements about hydrogen fuel cells are correct? The reaction between hydrogen and oxygen is endothermic. This is incorrect because this is called a hydrogen fuel cell. A cell is supposed to provide energy, not require energy. So the reaction between hydrogen and oxygen is exothermic, not endothermic. Next, the waste product in a hydrogen fuel cell is water. Yes, this is correct because hydrogen reacts with oxygen to produce water, making this an environmentally friendly alternative to the internal combustion engine. So this is correct. Next, a chemical reaction in the cell produces hydrogen, which is used as a fuel. No, hydrogen is required as a fuel for the chemical reaction that takes place in which hydrogen reacts with oxygen producing water. So this statement is incorrect. And the last one, a hydrogen fuel cell is used to generate electricity. Yes, that is the purpose of a hydrogen fuel cell, to provide electricity for the car to actually function. Therefore, since statements 2 and 4 are correct, option C is the correct option for this question. Question 14. Which change is a physical change? Copper 2 carbonate changes color from green to black when it is heated and stays black when it cools, because copper carbonate is converted into copper oxide, which is CuO. This is the salt that is black in color. So this is a chemical change, not a physical change. Next, ethanol reacts with oxygen to form carbon dioxide and water. This is called combustion, and combustion is a chemical change. Next, we have hydrogen peroxide decomposes into water and oxygen when it is boiled. This is also a chemical change. So this is incorrect as well. Ice forms liquid water when it is heated. So the change of state is from solid to liquid, which is a physical change and not a chemical change. Therefore, option D is the correct option for this question. Question 15. A student adds excess magnesium ribbon to 10 cm cube of 0.5 mole per dm cube sulfuric acid. The hydrogen gas is collected and its volume measured every 10 seconds. The experiment is repeated using the same mass of magnesium ribbon with 5 cm cube of 0.5 mole per dm cube sulfuric acid added to 5 cm cube of water. So basically, in the first experiment, the student used a greater number of moles of sulfuric acid, and since the volume is half and the concentration is the same, that means the number of moles used in the second experiment is half of the number of moles used in the first experiment. And since H2SO4 is producing hydrogen gas, so the molar ratio is 1:1. So if the moles of sulfuric acid are half, that means the volume of hydrogen gas produced will also be half in the case of the second experiment. So the question asks, which graph shows the results of the second experiment? In order to find that out, we need to find out the volume produced by the first experiment. So this is the volume produced. So a perpendicular is being drawn, and the perpendicular intersects the y-axis at 120 cm cube. So 120 cm cube are produced in experiment 1. So now when the concentration of sulfuric acid is half, so the volume of gas produced will also be half, which would be at 60 centimeter cube. So at 60 cm cube, we have the perpendicular intersecting the curve represented by option D. So this makes D the correct option for this question. Question 16. An equilibrium reaction is shown. N2O4 gas produces 2NO2 gas. The forward reaction is endothermic. What is the effect of changing the temperature and pressure on the equilibrium position? Okay, if you increase the temperature, since this is an endothermic reaction, increasing the temperature will shift the equilibrium forward and increasing the pressure. So the pressure, if increased, favors the side with the lesser number of moles. So N2O4 has 1 mole present and NO2 has 2 moles present. So since there are lesser moles of reactants, the equilibrium will shift towards the left. So this is what should happen. So moves to the left, incorrect, moves to the left, incorrect, moves to the right, correct, moves to the right, correct. And in the next column, moves to the left is correct, moves to the right is incorrect, moves to the left is correct, and moves to the right is incorrect. Therefore, since both the effects in option C are correct, option C is the correct option for this question. Question 17. In which reaction is the underlined compound acting as a reducing agent? So if it is acting as a reducing agent, then it should undergo oxidation. So in CO2, carbon has an oxidation state of +4, which is converted into carbon monoxide, in which carbon has an oxidation state of +2. So carbon is not undergoing oxidation, it is undergoing reduction, making this option incorrect. Next, carbon on the reactant side has an oxidation state of 0 because it is in its elemental form. And in the product side, it is turned into CO2, in which the carbon has an oxidation state of +4 which means carbon has been oxidized, making this the correct answer. Because it is oxidized, it acts as a reducing agent. In the next equation, we've got Fe2O3 with iron having a +3 charge on it. It is converted into iron metal on the product side. Being elemental iron, it will have an oxidation state of 0, meaning it is undergoing reduction, making it an oxidizing agent and making this equation incorrect. In the next reaction, we've got HCl, in which hydrogen has an oxidation state of +1 and chlorine has an oxidation state of -1. On the product side, chlorine retains its oxidation state of -1 and hydrogen retains its oxidation state of +1, making this reaction not a redox reaction, but in fact a neutralization reaction, because calcium carbonate is reacting with HCl. So this reaction is incorrect as well. Therefore, the correct option for this question is option B. Question 18. X, Y, and Z are oxides of elements in the same row of the periodic table. Some information about each oxide is shown. X is soluble in water. Ability to neutralize an acid is not there, but ability to neutralize an alkali is there, making X acidic. Y is insoluble in water, but is able to neutralize both acid and alkali, making it amphoteric in nature. And Z is slightly soluble in water, but it cannot neutralize an acid. Oh, it can neutralize an acid, but cannot neutralize a base. So since it can neutralize an acid, it is basic in nature. Therefore, the question asks, what type of oxides are X, Y, and Z? So X is acidic, Y is amphoteric, and Z is basic. So the row with all the correct types of oxide and their acid-base nature is represented by option A, making A the correct option for this question. Question 19. 4 different acids are dissolved in water. Which beaker contains the most concentrated strong acid solution? So strong acids are completely dissociated in aqueous solution and weak acids are partially dissociated. And concentrated acid would have more quantity of the acid compared to water, and not compared to water, in water. And dilute solution would have lesser quantity of the acid in water. So A has H positive and Z negative ions, making a strong acid. B has HY, H positive and Y negative in small quantities. So this is a weak acid since the molecular form of the acid is also present. Same is the situation in solution C. We've got the molecular form and the ionic form present together, making it a weak acid. And in D, we've got H positive and W negative ions, making it a strong acid. Now, we have two solutions of strong acid. Now, comparing their concentration, in A, we've got 1, 2, 3, 4, 5, 6, 6 moles of H positive ions in solution. And in D, we've got 1, 2, 3, 4, 4 moles of H positive ions in solution. So, comparing solutions A and D, A is a stronger acid, or rather it is more concentrated. To put it more correctly, the concentration is more for solution A, whereas in comparison, the concentration is less for solution D. So out of the 4 given solutions, the one with the most concentrated strong acid present in it is A, making option A the correct option for this question. Question 20. The following substances can be reacted together to prepare salts: copper 2 oxide and excess hydrochloric acid and excess sodium hydroxide, and hydrochloric acid and excess zinc carbonate. Okay. In which reactions can the excess reactant be separated from the solution by filtration. So since in the set of reactants in one, we've got excess of hydrochloric acid, all of the insoluble copper 2 oxide will react with acid, producing soluble copper 2 chloride, and none of the reactant would remain. So we will not have any precipitate of copper 2 oxide present in the final mixture. So we would not be able to separate the excess of reactant by filtration, because the excess reactant is hydrochloric acid and not copper 2 oxide. So one is not the answer here. 2, hydrochloric acid and excess sodium hydroxide. Both of these are soluble compounds. So when they react, they will form a salt, NaCl, which is soluble along with water. So since everything is soluble, nothing would be able to be separated by filtration. And the last one, hydrochloric acid and excess zinc carbonate. Now, zinc carbonate is an insoluble carbonate and it is in excess. So after all the hydrochloric acid has reacted with zinc carbonate, some of the zinc carbonate would remain as precipitate and will be able to be separated from the solution by filtration. So since 3 is the only correct answer, option D is the correct option for this question.